In the vast, icy expanse of the outer solar system, a colossal moon defies the norm, wielding a power usually reserved for planets. Ganymede, a behemoth larger than the planet Mercury and even bigger than the dwarf planet Pluto, is not just any moon. It's a titan with its own magnetic field, a shield against the relentless solar winds that batter its surface. This magnetic field, a cosmic rarity, is a key to understanding the mysteries of this distant world and the potential for life beyond Earth. Join us as we journey to this enigmatic moon, where the forces of nature paint a picture of a place unlike any other in our solar system. The celestial marvel, Ganymede. Ganymede, a celestial titan orbiting Jupiter, stands as a testament to the cosmos' boundless wonders. It is the largest moon in our solar system, even surpassing the planet Mercury in size. This colossal satellite boasts a diameter of about 5,268 kilometers, making it a true giant among moons. Its sheer magnitude is awe-inspiring, a silent sentinel in the vast expanse of space. Ganymede's size is not merely a point of interest. It is a gateway to understanding the unique phenomena that define this celestial body. One of the most remarkable features of Ganymede is its intrinsic magnetic field. This is a rare trait among moons, with only Earth's moon and a few others possessing such a characteristic. The magnetic field is generated by the motion of conductive fluids within Ganymede's interior, a process known as a dynamo. This field is significant because it interacts with Jupiter's own massive magnetic field, creating a complex and dynamic environment. The presence of a magnetic field suggests that Ganymede has a partially molten core, hinting at geological activity and a history of internal processes. This magnetic field also plays a crucial role in protecting Ganymede from the solar wind, a stream of charged particles emitted by the sun. By deflecting these particles, the magnetic field helps to preserve the moon's tenuous atmosphere and surface composition. Comparing Ganymede's size to that of planets underscores its grandeur. While it is not a planet itself, its diameter is larger than that of Mercury and nearly as large as Mars. This comparison is not just about size. It highlights the diversity and complexity of celestial bodies in our solar system. Ganymede's massive size and unique features make it a subject of intense study and fascination. Scientists believe that understanding Ganymede can provide insights into the formation and evolution of not just moons, but also planets. Its magnetic field, size, and potential for geological activity make it a key player in the ongoing exploration of our solar system. Ganymede's story is one of grandeur and mystery, a celestial marvel that continues to captivate and inspire. A moon of many firsts, Ganymede, a celestial titan orbiting the gas giant Jupiter, stands as a testament to the wonders of our solar system. It is the largest moon not just in the Jovian system, but in the entire solar system, surpassing even the planet Mercury in size. This colossal satellite is a moon of many firsts, and its most remarkable feature is the presence of its own magnetic field. This magnetic field is a rarity among moons, making Ganymede a unique and fascinating subject of study. The significance of this magnetic field cannot be overstated, as it provides a window into the moon's internal dynamics and offers clues about its geological history. The magnetic field of Ganymede is generated by a process known as a dynamo, similar to the one that creates Earth's magnetic field. This dynamo is believed to be the result of the motion of conductive fluids within Ganymede's iron-rich core. The presence of such a core suggests that Ganymede has undergone significant differentiation, with heavier elements sinking to the center and lighter ones rising to the surface. This process is indicative of a complex geological history, one that includes the possibility of a subsurface ocean. The magnetic field also interacts with Jupiter's own immense magnetic field, creating a spectacular display of auroras that dance across Ganymede's icy surface. In terms of size, Ganymede's magnetic field is a dwarf compared to those of the gas giants. Jupiter's magnetic field, for instance, is the largest and most powerful in the solar system, extending millions of kilometers into space. Saturn's magnetic field is also substantial, though not as vast as Jupiter's. Ganymede's magnetic field, while impressive for a moon, is relatively modest in comparison. However, Its very existence challenges our understanding of planetary bodies and their potential for harboring complex geological processes. The study of Ganymede's magnetic field provides valuable insights into the conditions necessary for the generation of such fields and the implications for the Moon's habitability. Ganymede's magnetic field also plays a crucial role in protecting the Moon from the harsh radiation emitted by Jupiter. The interaction between the two magnetic fields creates a protective bubble around Ganymede, shielding its surface from the relentless bombardment of charged particles. This shielding is essential for the preservation of any potential subsurface ocean, as it helps to maintain the necessary conditions for liquid water to exist. The presence of a magnetic field, combined with the evidence for a subsurface ocean, makes Ganymede a prime candidate in the search for extraterrestrial life. The study of this enigmatic moon continues to push the boundaries of our knowledge and inspire awe at the wonders of our solar system. Ganymede's discovery and naming. Ganymede, a celestial behemoth orbiting Jupiter, was first observed by the astronomer Galileo Galilei in 1610. Alongside three other Jovian moons, Io, Callisto, and Europa, Ganymede was one of the first celestial bodies discovered to be in orbit around a planet other than Earth. This revelation shattered the geocentric model of the universe, which placed Earth at the center and provided substantial evidence for the heliocentric model proposed by Copernicus. The discovery of Ganymede and the other Galilean moons marked a significant turning point in the history of astronomy, propelling our understanding of the cosmos into a new era. The moon was named after the mythical Ganymede, a Trojan prince in Greek mythology who was renowned for his beauty. According to the myth, Ganymede was abducted by Zeus, the king of the gods, who was captivated by the prince's beauty. Zeus then took Ganymede to Mount Olympus to serve as the cupbearer to the gods. This mythological connection is fitting, given that Ganymede is not only the largest moon in the solar system, but also the only one known to possess its own magnetic field. This magnetic field, though smaller than those of the gas giants, is a remarkable feature that sets Ganymede apart from other moons. Ganymede's magnetic field is a testament to the moon's unique geological activity. It is believed to be generated by a subsurface ocean of salty water, which interacts with Ganymede's rocky core to create a dynamo effect, similar to the process that generates Earth's magnetic field. This magnetic field is not just a scientific curiosity. It plays a crucial role in protecting Ganymede from the intense radiation emitted by Jupiter. The field deflects charged particles, creating a protective bubble around the moon. This is akin to how Earth's magnetic field shields us from solar winds, allowing life to thrive. In terms of size, Ganymede is a true giant. It is larger than the planet Mercury and nearly as large as Mars. If Ganymede were to orbit the Sun directly, it would easily be classified as a planet. Its diameter of 268 kilometers makes it a colossal presence in the Jovian system. The moon's immense size and unique features, including its magnetic field, make it a prime target for scientific study. Future missions, such as the European Space Agency's Jupiter Icy Moons Explorer JUICE mission, aim to explore Ganymede in greater detail, unraveling the mysteries of this enigmatic world. Ganymede in mythology. In the vast tapestry of celestial bodies, Ganymede stands out as a titan among moons, not just for its size, but also for its unique possession of a magnetic field. This magnetic field, a rarity among moons, is a testament to the dynamic nature of Ganymede. It generates a magnetosphere that interacts with Jupiter's own immense magnetic field, creating a complex and beautiful dance of charged particles. The significance of this magnetic field cannot be overstated. It provides a shield against the solar wind, much like Earth's magnetosphere protects our planet. This protective bubble allows for the existence of a tenuous atmosphere and possibly even subsurface oceans, making Ganymede a prime candidate in the search for extraterrestrial life. Ganymede's magnetic field is not just a scientific curiosity, it's a force to be reckoned with. In terms of size, it's comparable to that of some planets. For instance, its magnetosphere extends far into space, dwarfing even the magnetic fields of some smaller planets like Mercury. This magnetic prowess is a result of the moon's unique internal structure, which includes a likely subsurface ocean and a partially molten iron core. The interaction between these layers generates the magnetic field, a process similar to what happens within Earth's core. This makes Ganymede a fascinating subject for studying planetary magnetism and the potential for habitability beyond Earth. Delving into mythology, Ganymede's name carries a rich history. In Greek mythology, Ganymede was a beautiful young prince of Troy, known for his striking appearance and grace. His story is one of transformation and ascension. According to the myth, Zeus, the king of the gods, was so captivated by Ganymede's beauty that he transformed into an eagle and carried the prince to Mount Olympus. There, Ganymede became the cupbearer of the gods, a role of great honor and responsibility. This mythological significance adds a layer of intrigue to the celestial body, connecting the cold, distant moon to the vibrant stories of ancient Greece. The myth of Ganymede also carries symbolic weight. It represents the idea of transcendence, of being chosen for a higher purpose. This theme resonates with the scientific exploration of Ganymede, as it too has been chosen for its potential to reveal secrets about our solar system and the possibility of life elsewhere. The moon's magnetic field, its subsurface ocean, and its complex geology all point to a world that is far more dynamic and intriguing than initially thought. Just as the mythological Ganymede ascended to the heavens, the celestial Ganymede beckons us to look beyond our planet and explore the wonders of the cosmos. Ganymede's unique characteristics. Ganymede, a celestial titan orbiting Jupiter, stands as a marvel in our solar system, not merely for its size, but for its unique characteristics that set it apart from other moons. It is the largest moon in the solar system, even surpassing the planet Mercury in diameter, and it boasts a feature that is extraordinarily rare among moons: its own magnetic field. This magnetic field is a testament to the dynamic processes occurring within Ganymede, hinting at a complex interior that may harbor a subsurface ocean of liquid water. The significance of this magnetic field cannot be overstated, as it interacts with Jupiter's own immense magnetic field, creating a spectacular auroral display that rivals even the most vibrant scene on Earth. The magnetic field of Ganymede is a product of its internal dynamo, a mechanism driven by the motion of conductive fluids within its core. This is a characteristic typically associated with planets, not moons. In fact, among the moons in our solar system, only Ganymede and Saturn's moon, Titan, are large enough to potentially host such a dynamo. The field is about 10% as strong as Earth's, which might seem weak, but it is a powerful force in its own right. It creates a miniature magnetosphere around Ganymede, shielding it from the relentless solar wind and the intense radiation belts that surround Jupiter. This protective bubble is crucial for the moon's potential habitability, as it helps to maintain a more stable environment for any subsurface ocean that might exist. Comparing Ganymede's size to that of planets underscores its grandeur. With a diameter of about 268 kilometers, it is larger than both Mercury and Pluto, making it a true giant among moons. Its volume is even more impressive, as it could contain nearly 3 times the volume of our own moon. This sheer size contributes to its ability to generate and maintain a magnetic field. The field structure is dipolar, much like Earth's, with a north and south pole. This configuration is a result of the convective motion of molten iron or other conductive materials within its core. The interaction between this internal dynamo and the external magnetic field of Jupiter creates a complex and dynamic environment, one that is ripe for exploration and study. Ganymede's magnetic field also plays a crucial role in its geological activity. The tidal forces exerted by Jupiter's immense gravity cause the moon to flex and heat up, driving geological processes that might include volcanic activity and the movement of tectonic plates. These processes, in turn, contribute to the maintenance of the internal dynamo that generates the magnetic field. The field itself is not static. It varies over time, with fluctuations that can provide insights into the moon's internal structure and composition. Studying these variations can help scientists understand the processes that drive magnetic field generation not only on Ganymede, but also on Earth and other planets. In this way, Ganymede serves as a natural laboratory for studying the fundamental processes that shape our solar system. The largest moon in the solar system, Ganymede, a celestial titan orbiting Jupiter, stands as the largest moon in our solar system. Its diameter stretches an impressive 5,268 kilometers, surpassing even the planet Mercury. This colossal satellite is a world of its own, boasting a complex geology that includes vast plains, deep craters, and towering mountains. Its surface is a tapestry of ancient, heavily cratered regions juxtaposed with lighter, grooved terrains, hinting at a history of tectonic activity. Ganymede's sheer size and unique features make it a subject of fascination and intense study. One of Ganymede's most remarkable attributes is its intrinsic magnetic field, a rarity among moons. This magnetic field is a testament to the moon's dynamic interior, suggesting the presence of a subsurface ocean of salty water. The interaction between this ocean and Ganymede's iron-rich core generates the magnetic field, much like the dynamo effect observed on Earth. This field is not merely a scientific curiosity. It plays a crucial role in shielding Ganymede from the relentless solar wind and Jupiter's powerful magnetic environment. The existence of such a field raises intriguing possibilities about the moon's potential habitability and its ability to support life. In the grand cosmic ballet of our solar system, Ganymede's size and magnetic field set it apart. To put its dimensions into perspective, if Ganymede were to replace our moon, it would loom nearly 4 times larger in the night sky. Its magnetic field, though weaker than Earth's, is a staggering 0 times stronger than Jupiter's own magnetic field at the moon's location. This magnetic prowess is a testament to Ganymede's unique composition and internal processes. The study of this enigmatic moon offers valuable insights into the formation and evolution of planetary bodies, as well as the potential for life beyond Earth. Ganymede, with its grandeur and mystery, continues to captivate astronomers and space enthusiasts alike. Ganymede's distinctive appearance. Ganymede, a celestial titan among moons, is a world of stark contrasts and awe-inspiring features. Its surface is a patchwork of 2 distinct terrains, the lighter, grooved regions and the darker, ancient, heavily cratered areas. The lighter regions are a testament to the moon's geological activity, with intricate systems of ridges and grooves that stretch across its surface, reminiscent of a vast, frozen highway. These grooves, some as long as thousands of kilometers, are believed to be the result of tectonic processes, where the moon's icy crust has been pulled and pushed, creating these striking patterns. The darker regions, on the other hand, are a stark reminder of Ganymede's violent past, pockmarked with craters from countless impacts over the eons. The most striking feature of Ganymede, however, is its magnetic field. This is a rarity among moons, with only Earth's moon and a few others possessing such a feature. Ganymede's magnetic field is a testament to the moon's unique internal structure. It is believed to be generated by a subsurface ocean of salty water, which interacts with the moon's rocky core. This magnetic field is not just a scientific curiosity. It plays a crucial role in protecting Ganymede from the harsh solar winds that bombard the Jovian system. It creates a miniature magnetosphere around the moon, deflecting these charged particles and creating a safe haven for any potential life forms that might exist beneath its icy surface. In terms of size, Ganymede is a true giant. It is the largest moon in the solar system, even larger than the planet Mercury. If it were to orbit the Sun directly, it would easily be classified as a planet. Its diameter is a staggering 5,268 kilometers, making it a quarter the size of Earth. This immense size is not just a matter of scale. It also contributes to Ganymede's unique features. Its gravity is strong enough to hold onto a thin atmosphere, composed primarily of oxygen. This atmosphere, though tenuous, is a fascinating subject of study, offering insights into the moon's composition and history. Despite its distance from the Sun, Ganymede is a world of immense complexity and grandeur, a testament to the wonders of our solar system. A world of ice and rock. Ganymede, a celestial titan orbiting Jupiter, stands as a testament to the cosmic wonders that lie beyond our immediate solar neighborhood. This colossal moon, larger than both Mercury and Pluto, is a fascinating blend of ice and rock, a world that challenges our understanding of what a moon can be. Its surface, a patchwork of 2 distinct terrains, tells a tale of a violent past. Dark, Ancient and heavily cratered regions coexist with lighter, grooved areas, evidence of a complex geological history. The lighter areas, likely the result of tectonic activity, hint at a subsurface ocean that could potentially harbor life. The magnetic field of Ganymede is a marvel in itself, a rarity among moons. It is the only known moon with its own magnetosphere, a protective bubble that shields it from the relentless solar wind. This magnetic field, though a fraction of Earth's, is a significant feature, comparable in strength to that of some planets. It is generated by the motion of conductive fluids within Ganymede's iron-rich core, a process known as dynamo action. The presence of this magnetic field has profound implications. It interacts with Jupiter's own massive magnetic field, creating a spectacular aurora that dances across Ganymede's skies. Moreover, it provides a potential shield for any life that might exist in its subsurface ocean, protecting it from harmful radiation. In the grand tapestry of our solar system, Ganymede's size and magnetic field make it a standout. It is larger than Mercury and nearly as large as Mars, a fact that often surprises those who think of moons as mere satellites. Its magnetic field, though not as strong as Earth's, is a testament to its unique internal dynamics. It is a world that defies simple classification, a place where ice and rock coexist in a delicate balance. The study of Ganymede offers a window into the processes that shape our solar system, a chance to understand the forces that create worlds and the conditions that might foster life. It is a world of ice and rock, yes, but also a world of wonder and mystery, a testament to the grandeur of our cosmic neighborhood. Ganymede's orbit and rotation. Ganymede, a celestial titan among moons, orbits the gas giant Jupiter in a grand, elliptical path. This colossal satellite takes about 7 Earth days to complete one orbit, a journey that is both majestic and precise. Its orbit is synchronized with its rotation, a phenomenon known as tidal locking, which means Ganymede always presents the same face to Jupiter. This dance of cosmic proportions is a testament to the gravitational ballet that governs the Jovian system. The Moon's orbit is not a perfect circle but an ellipse, causing its distance from Jupiter to vary. At its closest approach, Ganymede is about 1.7 million kilometers from Jupiter, and at its farthest, it is about 1.37 million kilometers away. This variation in distance is a subtle reminder of the dynamic nature of celestial mechanics. The significance of Ganymede's magnetic field cannot be overstated. It is the only moon in our solar system known to possess such a field, a trait that sets it apart from its peers and aligns it more closely with planets like Earth. This magnetic field is a shield, protecting Ganymede from the relentless solar wind and the intense radiation belts that surround Jupiter. The field is generated by the motion of conductive fluids within Ganymede's iron-rich core, a process known as dynamo action. The strength of Ganymede's magnetic field is about 3 times weaker than Earth's, but it is a formidable force nonetheless. It creates a miniature magnetosphere around the Moon, a bubble of magnetic influence that interacts with Jupiter's own massive magnetosphere. This interaction creates a spectacle of auroras and plasma toruses, a visual testament to the power of magnetic fields. In terms of size, Ganymede's magnetic field is a dwarf compared to those of the gas giants. Jupiter's magnetic field, for instance, is the largest and most powerful in the solar system, extending millions of kilometers into space. Saturn's magnetic field is also vast, though not as strong as Jupiter's. Ganymede's magnetic field, while impressive for a moon, is a mere whisper in comparison. However, it is a giant among the other moons. None of the other moons in our solar system have a magnetic field of their own. This makes Ganymede a unique world, a moon with planetary characteristics. Its magnetic field is a beacon, a sign that this moon is more than just a rocky satellite. It is a world with a complex interior, a dynamic history, and a future that is as intriguing as it is mysterious. The intricate dance with Jupiter. Ganymede, a colossal moon of Jupiter, is a celestial body of immense grandeur and complexity. It is the largest moon in our solar system, even surpassing the planet Mercury in size. This titanic satellite is not just a passive companion to Jupiter. It engages in an intricate dance, a cosmic ballet, with the gas giant. At the heart of this dance lies Ganymede's unique magnetic field, a phenomenon that sets it apart from other moons and even some planets. The magnetic field of Ganymede is a testament to its internal dynamism. Unlike Earth's moon, which is a cold, dead rock, Ganymede possesses a molten core that generates a magnetic field. This field is a shield, a protective bubble against the solar wind and Jupiter's intense radiation belts. It's a marvel of nature, a testament to the moon's internal heat and the churning of its metallic core. The field is not as strong as Earth's, but it's significant enough to create a mini magnetosphere around Ganymede, a bubble of space dominated by the moon's magnetic influence. In the grand scheme of the solar system, Ganymede's magnetic field is a rare gem. Only a few planets, including Earth, have such fields. Among moons, Ganymede stands alone. This field interacts with Jupiter's own massive magnetic field, creating a complex web of forces. As Ganymede orbits Jupiter, it plows through the planet's magnetic field, generating electric currents and auroras. This interaction is a spectacle, a dance of charged particles and magnetic forces. It's a reminder of the dynamic and interconnected nature of our solar system, where even the smallest bodies can have a significant impact. The significance of Ganymede's magnetic field extends beyond its immediate vicinity. It provides a window into the moon's interior, offering clues about its composition and history. The field also influences the environment around Ganymede, shaping its thin atmosphere and surface chemistry. Moreover, it creates a unique environment for any potential life forms. While Ganymede's surface is a harsh, icy wasteland, the moon's magnetic field could help protect life in its subsurface ocean, a potential haven for extraterrestrial organisms. In this way, Ganymede's magnetic field is not just a scientific curiosity. It's a key player in the intricate dance with Jupiter, a dance that could have profound implications for our understanding of the solar system and our place in it. Ganymede's tidal heating. Ganymede, a colossal moon of Jupiter, stands as a testament to the wonders of our solar system. It is not just the largest moon in our celestial neighborhood, but also a unique celestial body possessing its own magnetic field. This magnetic field, a rarity among moons, is a product of Ganymede's dynamic interior, where a subsurface ocean of salty water likely interacts with rocky material to generate a self-sustaining dynamo. The significance of this magnetic field cannot be overstated. It shields Ganymede from the relentless solar wind, creating a complex magnetic environment that interacts with Jupiter's own immense magnetosphere. This interaction creates a spectacular auroral display, a dance of charged particles that lights up Ganymede's polar regions. The magnetic field also provides crucial insights into the moon's internal structure and composition, offering a window into the processes that drive its geologic activity. Tidal heating, a process driven by the gravitational tug-of-war between Jupiter and its moons, plays a pivotal role in Ganymede's internal dynamics. As Ganymede orbits Jupiter, the planet's immense gravity squeezes and stretches the moon, generating frictional heat within its interior. This heat is thought to be sufficient to maintain a subsurface ocean of liquid water, despite the frigid temperatures at Ganymede's surface. The magnitude of this tidal heating is staggering. It is estimated that Ganymede experiences tidal heating rates comparable to those of some of the most geologically active bodies in our solar system, such as Jupiter's moon Io. This heat drives convection within Ganymede's rocky mantle, potentially powering the dynamo that generates the moon's magnetic field. It also contributes to the formation of the moon's intricate surface features, including its vast system of grooves and ridges. The size of Ganymede's magnetic field is a testament to the moon's grandeur. It is embedded within a vast magnetosphere that extends far into space, dwarfing the magnetic fields of other moons in our solar system. In fact, Ganymede's magnetic field is so large that it would be considered a planet in its own right if it orbited the Sun directly. Its magnetosphere is a dynamic and complex structure, shaped by the interplay of Ganymede's own magnetic field and the external magnetic field of Jupiter. This interaction creates a unique environment that is rich in plasma and charged particles, offering a wealth of opportunities for scientific exploration. The study of Ganymede's magnetic field and its interaction with Jupiter's magnetosphere provides valuable insights into the processes that shape planetary magnetic fields and the environments they create. It also offers a glimpse into the potential habitability of icy moons, as the magnetic field may play a crucial role in protecting any subsurface oceans from the harsh radiation of space. A magnetic field of its own, Ganymede, a celestial titan orbiting Jupiter, is a marvel of the solar system, not least because it possesses a magnetic field of its own. This is a rarity among moons, a distinction shared only with a few other celestial bodies. The magnetic field of Ganymede is a testament to its unique internal dynamics, driven by a subsurface ocean of salty water and a molten iron core. This magnetic field, though modest compared to Earth's, is a powerful force in its own right, creating auroras and shielding the moon from the relentless solar wind. In the grand tapestry of the cosmos, Ganymede's magnetic field stands out. It is dwarfed by the magnetic fields of gas giants like Jupiter and Saturn, which are immense and complex. Yet, Ganymede's field is comparable in strength to that of Mercury, the smallest planet in our solar system. This is a staggering comparison, considering Mercury's field is generated by a planetary core, while Ganymede's is produced by a moon. The field extends far into space, creating a magnetosphere that interacts with Jupiter's own magnetic field, a dance of cosmic forces visible in the form of stunning auroras. The significance of Ganymede's magnetic field cannot be overstated. It provides a shield against the harsh radiation emanating from Jupiter, protecting the moon's surface and potentially any life that might exist in its subsurface ocean. This field also offers scientists a window into the moon's interior, revealing clues about its composition and evolution. By studying Ganymede's magnetic field, researchers gain insights into the processes that drive planetary bodies, both within and beyond our solar system. It is a beacon of knowledge, illuminating the mysteries of the cosmos. The enigma of Ganymede's magnetosphere. Ganymede, a colossal moon of Jupiter, stands as a celestial marvel, not merely for its size but for its possession of a magnetic field, a rarity among moons. This magnetosphere, a bubble of charged particles, is a testament to the moon's unique internal dynamics. Unlike Earth's magnetic field, which is generated by a dynamo effect in its molten outer core, Ganymede's magnetic field is likely produced by the motion of conductive material within its subsurface ocean or its iron-rich core. The significance of this magnetic field is profound, as it interacts with Jupiter's own immense magnetosphere, creating a complex and dynamic electromagnetic environment. In scale, Ganymede's magnetic field is a dwarf compared to those of planets, but it is a giant among moons. It is roughly 1/10 the strength of Earth's magnetic field, yet it extends far into space, creating a protective shield against solar winds and cosmic radiation. This magnetosphere is so extensive that it even influences the behavior of charged particles within Jupiter's magnetosphere, demonstrating the moon's substantial influence despite its status as a satellite. The interaction between Ganymede's magnetic field and Jupiter's magnetosphere creates a unique electromagnetic environment, filled with intricate plasma structures and dynamic phenomena. The enigma of Ganymede's magnetosphere lies in its complexity and the questions it raises about the moon's internal structure and composition. Scientists believe that the magnetic field is generated by a dynamo effect, similar to Earth's, but the exact mechanism remains a subject of debate. One leading theory suggests that the field is generated by the motion of conductive material within a subsurface ocean of salty water. Another theory proposes that it arises from the convection of molten iron in Ganymede's core. The truth likely lies in a combination of these factors, but the exact details are still shrouded in mystery. Understanding Ganymede's magnetic field is not just an academic exercise. It provides insights into the moon's potential habitability and the processes that shape planetary bodies throughout the universe. Ganymede's interaction with Jupiter's magnetosphere. Ganymede, a celestial titan among moons, is a world of firsts and superlatives. It is the largest moon in the solar system, even surpassing the planet Mercury in size. But what truly sets Ganymede apart is its possession of a magnetic field, a rarity among moons, and a characteristic typically reserved for planets. This magnetic field, a dynamic and complex force, interacts in a cosmic dance with the immense magnetosphere of its parent planet, Jupiter. The significance of this interaction cannot be overstated. It provides a unique laboratory for studying the behavior of magnetic fields in space, offering insights into the workings of planetary magnetospheres and the processes that generate them. Moreover, it influences the environment around Ganymede, shaping its radiation belts and affecting its tenuous atmosphere. The magnetic field of Ganymede, though modest by planetary standards, is a formidable force in its own right. It is induced by the motion of conductive fluids within Ganymede's subsurface ocean, a vast and briny expanse that lies beneath its icy crust. This ocean, kept liquid by the tidal forces exerted by Jupiter, generates a magnetic field that is about a tenth as strong as Earth's. Yet, despite its relative weakness, this field is strong enough to carve out a distinct cavity within Jupiter's magnetosphere, a region of space dominated by the gas giant's powerful magnetic field. This interaction creates a complex and dynamic environment, where charged particles from Jupiter's magnetosphere are deflected, accelerated, and trapped, forming intricate radiation belts around Ganymede. When Jupiter's magnetosphere sweeps past Ganymede, it does so with a force that is nothing short of awe-inspiring. The gas giant's magnetic field, the largest and most powerful in the solar system, dwarfs that of Ganymede. It is a titanic force, capable of trapping and accelerating charged particles to near-light speeds. As this magnetosphere interacts with Ganymede's own magnetic field, it creates a spectacle of cosmic proportions. Charged particles are funneled along magnetic field lines, creating auroras that dance and shimmer across Ganymede's icy surface. These auroras, though invisible to the naked eye, are a testament to the power and complexity of the interaction between these two magnetic fields. They are a reminder of the dynamic and ever-changing nature of the space environment, where forces on a planetary scale shape the destiny of moons and planets alike. The interaction between Ganymede's magnetic field and Jupiter's magnetosphere is not merely a spectacle. It is a process that shapes the very environment around the Moon. Charged particles from Jupiter's magnetosphere, deflected and accelerated by Ganymede's magnetic field, create a harsh and radiation-filled environment. This radiation, though deadly to life as we know it, is a crucial factor in shaping the chemistry and physics of Ganymede's surface and atmosphere. It drives the formation of complex molecules, alters the composition of ices, and influences the behavior of the Moon's tenuous atmosphere. In this way, the interaction between Ganymede's magnetic field and Jupiter's magnetosphere is a driving force in the evolution of the Moon, a process that has been ongoing for billions of years. It is a testament to the power of magnetic fields in shaping the destiny of worlds, both large and small. The auroras of Ganymede. Ganymede, a celestial titan among moons, is a world of wonders, none more captivating than its auroras. These ethereal light displays are not merely beautiful, they are a testament to the Moon's unique magnetic field, a rarity in our solar system. Unlike most moons, Ganymede boasts a magnetic field comparable in strength to that of some planets. This field, generated by the churning of molten iron in its core, is a shield against the solar wind, a stream of charged particles emanating from the sun. The interaction between this magnetic field and the solar wind is the birthplace of Ganymede's auroras. The auroras of Ganymede are a spectacle of nature's grandeur. They are caused by the precipitation of charged particles along the magnetic field lines, which then collide with the gases in the Moon's tenuous atmosphere. This collision excites the atmospheric gases, causing them to emit light in a process similar to what creates Earth's auroras. However, Ganymede's auroras are unique. They are not confined to the polar regions like Earth's. Instead, they can occur anywhere on the Moon's surface, creating a mesmerizing dance of light that can last for hours. The significance of Ganymede's magnetic field extends beyond creating stunning auroras. It provides a protective bubble around the Moon, shielding its surface and potential subsurface oceans from the harsh radiation of space. This magnetic field is so strong that it even interacts with Jupiter's massive magnetic field, creating a complex and dynamic electromagnetic environment. In fact, Ganymede's magnetic field is so powerful that it is the only moon in our solar system known to have one. This makes Ganymede a unique laboratory for studying the magnetic fields of celestial bodies. Moreover, the study of Ganymede's auroras and magnetic field provides valuable insights into the moon's interior and its potential habitability. The presence of a magnetic field suggests that Ganymede has a molten core, which could be a source of heat for a subsurface ocean. This ocean, shielded by the magnetic field, could potentially harbor life. Thus, the auroras of Ganymede are not just a beautiful phenomenon. They are a beacon guiding scientists in the search for life beyond Earth. Ganymede's subsurface ocean. Beneath the icy surface of Ganymede, Jupiter's largest moon, lies a hidden marvel, a vast subsurface ocean. This isn't just any body of water. It's a salty, possibly slushy, global ocean that could be 10 times deeper than Earth's oceans. The existence of this ocean is inferred from the moon's magnetic field, a rare feature among moons in our solar system. Ganymede's magnetic field is generated by the motion of its conductive, iron-rich core, but it also interacts with Jupiter's massive magnetic field, creating a complex and dynamic environment. This interaction provides compelling evidence for the presence of a subsurface ocean, as the saltwater likely contributes to the generation of Ganymede's magnetic field. The significance of Ganymede's magnetic field cannot be overstated. It's the only moon in our solar system known to have one, making Ganymede a unique celestial body. The magnetic field is strong enough to create its own magnetosphere, a protective bubble that shields the moon from the relentless solar wind. This magnetosphere is dwarfed by those of planets like Earth and Jupiter, but it's a giant compared to other moons. For instance, Earth's magnetosphere extends about 60 kilometers into space, while Ganymede's reaches a mere 10 kilometers. Despite its relatively small size, this magnetosphere plays a crucial role in protecting Ganymede's surface and subsurface ocean from harmful radiation. Comparing Ganymede's size to planets, it's a behemoth among moons. It's larger than Mercury and nearly as large as Mars. Yet, it's just a third of Earth's size. Despite its size, Ganymede's subsurface ocean is a testament to the moon's complexity and potential for harboring life. The ocean is likely sandwiched between layers of ice, with the upper layer being pure ice and the lower layer possibly containing ice and water mixed together. The exact thickness of the ice layers in the ocean is still a topic of scientific debate, but estimates suggest the ocean could be around 100 kilometers deep. This makes it a prime target for future exploration, as it could provide insights into the potential habitability of icy moons in our solar system and beyond. Evidence for a hidden sea. Ganymede, a celestial titan among moons, is a world of wonders, none more intriguing than the evidence pointing to a vast, hidden sea beneath its icy surface. This isn't just any moon. It's a colossus, larger than the planet Mercury and even bigger than some of the solar system's planets. Its magnetic field, a rare and awe-inspiring feature for a moon, is a key player in the symphony of clues hinting at this subterranean ocean. The magnetic field, generated by the churning of molten iron in its core, is a testament to Ganymede's dynamic nature. It's a force field that stretches out into space, interacting with Jupiter's own magnetic field in a cosmic dance. This interaction creates a complex web of electromagnetic forces that scientists have been able to study, providing tantalizing glimpses into the moon's interior. The size of Ganymede's magnetic field is nothing short of impressive. It's a bubble of magnetism that extends far into space, a shield against the solar wind that bombards the Jovian system. This field is strong enough to create auroras, much like those seen on Earth, but with a unique twist. Ganymede's auroras don't dance wildly in response to Jupiter's magnetic field, as one might expect. Instead, they remain relatively stable, a puzzling behavior that scientists have attributed to the presence of a large, conductive layer beneath the surface. This layer, they hypothesize, could very well be a vast, salty ocean, acting like a giant capacitor that smooths out the fluctuations in the magnetic field. The evidence for this hidden sea isn't just confined to magnetic field data. Ganymede's surface, a mosaic of two distinct types of terrain, tells a story of a world shaped by tectonic activity. The younger, grooved terrain is a testament to the moon's geologic past, a time when the interior was warm enough to drive the movement of the icy crust. This warmth, scientists believe, could have been generated by the same processes that create the magnetic field today. The older, darker regions, on the other hand, are pockmarked with craters, a silent testament to the eons of bombardment that have shaped the moon's surface. Yet, even in these ancient landscapes, there are signs of past geologic activity, hinting at a history of subsurface oceans that may have risen to the surface in the distant past. The significance of Ganymede's magnetic field and the evidence for a hidden sea extends far beyond mere scientific curiosity. It's a beacon of hope in the search for life beyond Earth. If Ganymede does indeed harbor a vast, subterranean ocean, it could be a potential habitat for life, a place where extraterrestrial organisms might have found a foothold in the cold, dark depths. The study of Ganymede, therefore, isn't just about understanding a moon. It's about understanding our place in the cosmos, about exploring the possibilities of life in the universe. It's a journey that begins with a single, giant step onto the surface of a moon, a journey that could one day lead us to the shores of an alien sea. The potential for life. Ganymede, a celestial titan orbiting Jupiter, stands as a beacon of intrigue in our solar system. It is not just the largest moon in our cosmic neighborhood, but also a colossus that dwarfs even the planet Mercury. This icy giant, with its diameter of 268 kilometers, is a world unto itself, boasting a complex geography of craters, grooves, and vast polar caps. But what truly sets Ganymede apart is its possession of a magnetic field, a rare and awe-inspiring feature that hints at a dynamic interior and a potential haven for life. The magnetic field of Ganymede, though a fraction of Earth's, is a monumental achievement in the realm of moons. It is generated by the motion of conductive fluids within Ganymede's iron-rich core, a process known as dynamo action. This magnetic field is not merely a scientific curiosity. It serves as a protective shield, deflecting the relentless solar wind and cosmic radiation that bombard the Jovian system. On Earth, this shield is crucial for the preservation of our atmosphere and the existence of life as we know it. On Ganymede, it raises tantalizing questions about the potential for a subsurface ocean sheltered from the harsh realities of space. Beneath Ganymede's icy crust, scientists speculate, lies a vast ocean of liquid water, kept warm by the tidal forces exerted by Jupiter's immense gravity. This subterranean sea, if it exists, would be a prime candidate in the search for extraterrestrial life. The presence of a magnetic field is a strong indicator of a dynamic interior, suggesting that Ganymede's ocean could be in contact with a rocky seafloor. On Earth, hydrothermal vents at the ocean floor support thriving ecosystems, teeming with life forms that rely on chemosynthesis rather than sunlight. If similar conditions exist on Ganymede, they could provide the necessary ingredients for life to emerge and flourish. Moreover, Ganymede's magnetic field interacts with Jupiter's own colossal magnetosphere, creating a unique environment that could facilitate the production of complex organic molecules. These molecules, the building blocks of life, could potentially rain down onto Ganymede's surface or be transported to its subsurface ocean. The combination of a protective magnetic field, a potential subsurface ocean, and the presence of organic molecules paints a picture of Ganymede as a world that is not only capable of harboring life, but also actively nurturing it. As we continue to explore our solar system, Ganymede stands as a testament to the boundless possibilities that lie beyond our home planet. Ganymede's thin oxygen atmosphere. Ganymede, a celestial titan among moons, boasts a magnetic field so robust it rivals those of some planets. This colossal moon, orbiting the gas giant Jupiter, is not just the largest in our solar system, but also the only one known to possess its own magnetic field. This magnetic field, a testament to Ganymede's unique geology, is generated by the motion of its likely liquid iron core, much like Earth's own dynamo. The significance of this magnetic field cannot be overstated. It creates a protective magnetosphere that shields Ganymede from the relentless solar wind, a stream of charged particles emanating from the sun. This magnetosphere is a complex and dynamic structure, interacting with Jupiter's own immense magnetic field in a cosmic dance of electromagnetic forces. In terms of scale, Ganymede's magnetic field is a dwarf compared to Jupiter's, but it is a giant among moons. It is even larger than the magnetic fields of planets like Mercury and Mars. The field extends far into space, creating a bubble of protection that encompasses the moon entirely. This magnetosphere is not static. It pulsates and shifts in response to changes in the solar wind and Jupiter's magnetic environment. The interactions between Ganymede's magnetic field and Jupiter's create spectacular auroras, visible as glowing curtains of light in the moon's polar regions. These auroras are not just beautiful. They are a visible testament to the complex electromagnetic interactions occurring in the Jovian system. Ganymede's thin oxygen atmosphere is a fascinating and enigmatic feature. Unlike Earth's atmosphere, which is rich in nitrogen and oxygen, Ganymede's atmosphere is tenuous and composed mostly of oxygen, with traces of ozone. This atmosphere is so thin that it is often referred to as an exosphere, a region where atoms and molecules are so sparse that they rarely collide with each other. The oxygen in Ganymede's atmosphere is not a product of life, as it is on Earth. Instead, it is likely generated by the interaction of solar radiation and charged particles from Jupiter's magnetic field with the moon's icy surface. These interactions cause water ice to break down into its constituent elements, releasing oxygen and hydrogen into the atmosphere. The presence of an oxygen atmosphere, even a thin one, has significant implications for Ganymede's potential habitability. While the conditions on Ganymede are far from hospitable to life as we know it, the presence of oxygen suggests that the moon has the potential to support certain chemical processes that could be precursors to life. Additionally, the interaction between Ganymede's magnetic field and its atmosphere creates a complex and dynamic environment that is ripe for scientific exploration. Future missions to Ganymede, such as the European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, aim to study this environment in detail, shedding light on the moon's potential to support life and its role in the Jovian system. Exploring Ganymede, past and future missions. Ganymede, a colossal moon of Jupiter, stands as a testament to the wonders of our solar system. It is not just the largest moon in our celestial neighborhood, but also a unique entity possessing its own magnetic field. This magnetic field, a rarity among moons, is a crucial aspect that sets Ganymede apart. It interacts with Jupiter's massive magnetosphere, creating a spectacular auroral display and offering scientists a natural laboratory to study magnetospheric dynamics. The significance of this magnetic field cannot be overstated, as it provides insights into the moon's internal structure and the complex interactions between celestial bodies. In terms of size, Ganymede's magnetic field is a dwarf compared to those of planets, but a giant among moons. It is about 1/10 the strength of Earth's magnetic field, yet it is 3 times larger than our planets in terms of the volume of space it influences. This magnetic bubble, known as the magnetosphere, extends far into space, shielding Ganymede from the solar wind and Jupiter's intense radiation belts. The sheer scale of this magnetic field is a testament to the dynamic processes occurring within Ganymede, hinting at a subsurface ocean of liquid water and a molten iron core. Past missions have provided a wealth of data about Ganymede, with the Galileo spacecraft being the most prolific. Galileo's flybys revealed the moon's magnetic field and provided detailed images of its surface, showcasing a complex landscape of 2 types of terrain: bright, grooved areas and older, darker regions marked by impact craters. These observations have fueled scientific curiosity and paved the way for future exploration. Upcoming missions, such as the European Space Agency's JUICE, Jupiter Icy Moons Explorer mission, aim to delve deeper into Ganymede's mysteries. JUICE, set to arrive at Jupiter in 2029, will conduct detailed investigations of Ganymede, including studying its magnetic field, searching for a subsurface ocean, and exploring its potential habitability. The future of Ganymede exploration holds immense promise. Scientists hope to uncover the secrets of its magnetic field, understand the processes driving its internal activity, and determine if it could harbor life. The data collected from these missions will not only enhance our understanding of Ganymede, but also provide valuable insights into the formation and evolution of our solar system. As we continue to explore this enigmatic moon, we edge closer to unraveling the mysteries of our cosmic neighborhood and our place within it. The Galileo mission's discoveries. Ganymede, a celestial titan among moons, is a world of wonders, and its magnetic field is a testament to its grandeur. This colossal moon, orbiting the gas giant Jupiter, is the only known moon in our solar system to possess its own magnetic field. The Galileo mission, a pioneering endeavor by NASA, unveiled this astonishing feature, forever changing our understanding of planetary bodies. The magnetic field of Ganymede, though dwarfed by that of Earth, is a marvel in its own right. It is about a tenth as strong as Earth's, yet it is a colossus compared to the fields of other moons. This magnetic field is not just a curiosity. It is a dynamic force that interacts with Jupiter's own immense magnetosphere, creating a complex and ever-changing environment around Ganymede. The significance of Ganymede's magnetic field cannot be overstated. It is a clue to the moon's internal structure and composition. Scientists believe that the field is generated by a subsurface ocean of liquid, salty water, which is kept liquid by the tidal forces exerted by Jupiter. This ocean, hidden beneath a thick crust of ice, could be a potential habitat for life. The magnetic field also creates auroras on Ganymede, much like those seen on Earth. These auroras, though not visible to the naked eye, have been detected by the Hubble Space Telescope. They are a stunning display of the interaction between Ganymede's magnetic field and the charged particles from Jupiter's magnetosphere. Comparing Ganymede's magnetic field to those of planets reveals its unique status. It is the only moon known to have a magnetic field, a distinction that sets it apart from even the largest moons in our solar system, such as Saturn's Titan and Jupiter's Callisto. In terms of size, Ganymede's magnetic field is comparable to that of Mercury, the smallest planet in our solar system. However, Mercury's field is generated by a molten core, while Ganymede's is likely generated by a subsurface ocean. This difference highlights the diversity of magnetic field generation mechanisms in our solar system. The Galileo mission's discoveries have opened up a new realm of possibilities for understanding the magnetic fields of planetary bodies, both within our solar system and beyond. Upcoming missions: JUICE and Europa Clipper. Ganymede, a celestial titan among moons, boasts a magnetic field so potent it rivals those of planets. This colossal satellite of Jupiter is not merely the largest moon in our solar system. It is a world unto itself, a testament to the cosmic wonders that lie beyond our terrestrial realm. Its magnetic field, a shimmering bubble of charged particles, is a marvel of nature, a shield against the relentless solar wind that bombards the Jovian system. This magnetic field is a key player in the intricate dance of particles and energy that defines the environment around Jupiter, a symphony of forces that scientists are only beginning to understand. In the grand tapestry of our solar system, Ganymede's magnetic field stands as a beacon of intrigue. It is a dwarf compared to the mighty fields of Jupiter and Saturn, but it is a giant among moons. Only Earth and the gas giants possess stronger magnetic fields, a testament to Ganymede's unique composition and dynamic interior. This magnetic field is not a static entity. It is a living, breathing part of Ganymede, shaped by the moon's rotation and the interactions with Jupiter's own magnetic field. It is a dynamic force, a protector, and a creator of auroras that dance across the moon's icy surface. The significance of Ganymede's magnetic field extends far beyond its immediate vicinity. It offers a window into the moon's interior, hinting at a subsurface ocean of liquid water that could harbor life. The magnetic field's interaction with Jupiter's magnetosphere creates a complex environment that scientists believe could provide the necessary energy and chemistry for life to emerge. This makes Ganymede a prime target for future exploration, a potential oasis of life in the cold, dark expanse of the outer solar system. Two upcoming missions, JUICE and Europa Clipper, are poised to unravel the mysteries of Ganymede and its magnetic field. The European Space Agency's JUICE, Jupiter Icy Moons Explorer, mission will perform detailed investigations of Jupiter and its three large ocean-bearing moons, including Ganymede. It will study the Moon's magnetic field, its interaction with Jupiter's magnetosphere, and the potential habitability of its subsurface ocean. Meanwhile, NASA's Europa Clipper will focus on Europa, another of Jupiter's moons, but it will also provide valuable data on Ganymede during its flybys. Together, these missions promise to revolutionize our understanding of Ganymede and its magnetic field, shedding light on the enigmatic world that lies beneath its icy surface. Ganymede as a future exploration destination. Ganymede, a celestial titan among moons, stands as a beacon of intrigue and potential in our solar system. It is not just the largest moon of Jupiter, but also the largest in our entire solar system, even surpassing the planet Mercury in size. This colossal moon is a world of its own, boasting a diameter of about 268 kilometers and a surface area larger than that of all the dwarf planets combined. Its sheer size is a testament to the grandeur of our cosmic neighborhood, offering a tantalizing destination for future exploration. One of Ganymede's most remarkable features is its intrinsic magnetic field, a rarity among moons. This magnetic field is a product of the moon's iron-rich core, which generates a dynamo effect similar to that of Earth. The presence of this magnetic field is significant for several reasons. It creates a mini-magnetosphere around Ganymede, shielding it from the intense radiation belts that Jupiter generates. This protection could potentially make certain areas of Ganymede more habitable for future human explorers or even native life forms. Additionally, studying this magnetic field provides valuable insights into the moon's internal structure and the processes that drive its geophysical activity. Comparing Ganymede's magnetic field to those of planets reveals its impressive scale. While it is much weaker than Earth's, it is still substantial enough to create a distinct magnetic environment. In fact, Ganymede's magnetic field is the only one known to exist among the moons of our solar system. This unique characteristic sets it apart from other celestial bodies and underscores its importance as a subject of scientific study. The interaction between Ganymede's magnetic field and Jupiter's own immense magnetosphere creates a complex and dynamic system that scientists are eager to explore further. The potential for future exploration of Ganymede is immense. Its magnetic field, combined with its size and geological diversity, makes it a prime candidate for in-depth study. Scientists are particularly interested in investigating the moon's subsurface ocean, which is believed to exist beneath its icy crust. This ocean could harbor conditions suitable for life, making Ganymede a key target in the search for extraterrestrial life within our solar system. Moreover, the moon's magnetic field provides a natural laboratory for studying the interactions between planetary bodies and their parent stars, offering insights that could be applied to other worlds. As we look to the future, Ganymede stands as a symbol of the boundless possibilities that lie within our reach. Its magnetic field, size, and potential for harboring life make it a compelling destination for exploration. By studying this enigmatic moon, we can deepen our understanding of the universe and our place within it. The journey to Ganymede is not just a scientific endeavor, but a testament to human curiosity and our relentless pursuit of knowledge. The mysteries that remain. Ganymede, a celestial titan orbiting Jupiter, stands as a testament to the cosmos' boundless enigmas. Among its most captivating features is its intrinsic magnetic field, a rarity among moons and a characteristic typically reserved for planets. This magnetic field, though a fraction of Earth's, is a formidable force in its own right, generating auroras that dance across its icy surface. The significance of this magnetic field cannot be overstated. It acts as a protective shield, deflecting solar winds and cosmic radiation, much like Earth's magnetosphere. This dynamic interaction with Jupiter's magnetic field creates a complex electromagnetic environment, offering scientists a unique natural laboratory to study plasma physics and magnetospheric dynamics. In the grand cosmic ballet, Ganymede's magnetic field is a soloist, a moon with the audacity to possess a feature typically seen in planets. To put its size into perspective, Ganymede's magnetic field is about a third as strong as Earth's. This might seem modest, but consider that Ganymede is a moon, not a planet. Its magnetic field is generated not by a molten iron core like Earth's, but by the motion of conductive fluids within its subsurface ocean. This makes Ganymede's magnetic field a beacon of hope in the search for extraterrestrial life, as it suggests the presence of a hidden ocean that could potentially harbor life. Yet, the mysteries of Ganymede's magnetic field run deeper than mere measurements. The interaction between Ganymede's magnetic field and Jupiter's is a complex waltz, with Ganymede's field being partially canceled out by Jupiter's. This creates a unique magnetic environment, with a magnetic umbrella that protects Ganymede's surface from Jupiter's intense radiation belts. The precise dynamics of this interaction remain an active area of research, with scientists using data from missions like NASA's Galileo and the upcoming Jupiter Icy Moons Explorer, JUICE, to unravel its secrets. Each new discovery adds another layer to the enigma that is Ganymede, a moon that continues to challenge our understanding of the cosmos. As we conclude our journey to Ganymede, let's recap the marvels we've uncovered. This colossal moon, larger than the planet Mercury and even our own moon, is a celestial powerhouse with its own magnetic field. This isn't just any magnetic field. It's a testament to Ganymede's unique internal dynamics, a shield against the solar wind, and a key player in the intricate dance of Jupiter's magnetosphere. In fact, Ganymede's magnetic field is so impressive that it's the only moon in our solar system known to have one, making it a true cosmic oddity. Imagine, if you will, standing on Ganymede's surface, gazing up at a sky dominated by the swirling storms of Jupiter. The magnetic field, invisible yet mighty, stretches out like an invisible force field, a silent guardian against the harsh realities of space. It's a sight that would humble even the most seasoned space explorer. But our exploration doesn't end here. The universe is vast, and there's always more to discover. If you've enjoyed unraveling the mysteries of Ganymede, stay tuned for our next adventure. We'll be diving into the enigmatic world of Europa, another of Jupiter's moons, where a hidden ocean beneath its icy surface hints at the possibility of life. Will Europa hold the key to one of humanity's greatest questions? Join us to find out. Until then, keep your eyes on the stars and your heart filled with wonder. The cosmos is calling, and we're here to answer. See you next time, fellow explorers.